All right, I'm going to try and do number 11 here as quick as I can. There's a whole bunch of stuff going on here. So the first thing I'm going to do is take care of this square root symbol. All right, when you have the square root of something like the square root of 4, another way to write that, this has an index of 2. That's why it's called a square root. When we square something, right, we put a little 2 there. So this is called a square root. And what it means is the same thing as raising it to a half power. This 2 and this 2 are identical. And that's just a notation. This is just a notation that means square root the 4, and so I could square root the 4. That'd be 2 to the first, which is 2. So if I got a radical, I can change it to an exponent by putting the exponent, this one has an exponent of 1 on top, and the index, that's the index of the radical, in the denominator. So here, my index is a 2. They don't show it on square roots, but there's a 2 on this little radical house. So this whole thing, instead of being to the 6th power, could be written as 1 over the cube root of x. And I'd write it to the exponent is a 6, but the index is a 2. And so I've gotten rid of that big square root by using that notation. And now I can use exponent rules that say, hey, this 6 over 2 is just a 3. It's not even an exponent rule at that. It's just 6 divided by 2 is 3. Now I got to cube everything. And so again, I'm going to use this as my exponent, and there's no root. This one isn't under a root, so I don't have any denominator on it. I'm going to get rid of that. And then the other one has a root, so this is an x. The exponent on it is the 3 because it's getting cubed, but the index is also a 3, so it's getting divided by 3, that exponent is. Well, 1 cubed is 1, and 3 divided by 3 is 1, so this is 1 over x. Tough problem, I think. Shooting through the rest of these things, these are all solved basically by the square root method. So what you want to do is just identify what is being squared. In this case, the x minus 5 is squared. And so you just go about the business of trying to get that squared part, the x minus 5 alone. So I undo additions first. That gives me 36. I divide by 2 second. I'm trying to get the squared part alone. So there we go, x minus 5 squared. It's now alone on the right, or the left side rather, and the right side is an 18. Okay. Then once the radical is by, or the squared part is by itself, then you can just square root both sides. Okay. And when I square root the left side, since it's squared and then I square root it, they just cancel each other out. On the right side here, I always get plus or minus when I square root, and it's the root of 18. And I think we've dealt with these square roots before. And this is where you can make a little factor tree. It's 9 times 2, and you look for things, look for factors that are perfect square roots, like 9 can be square rooted, it's 3. And so I get plus or minus 3 root 2 on the right, and I just have to get that 5 over there. So I add 5 to both sides. Don't ever add that 5 to that radical part. Just put the 5 out in front of the plus or minus. And that's your answer right there. Looks like I went too far, Mr. Todd. They did not simplify it. They stopped right here. They square rooted both sides. They just left the 18, so they get x equals 5 plus or minus root 18. So they didn't go as far as I went. They should. We got to find the roots of this guy. This guy has a squared part in it, but it's not written with all the x's inside of it. Here's what I mean by that. If I looked at this problem, the only x's are trapped inside the squared, and that's why isolating that worked. But here, there's an x squared, but there's also this x that's outside of it. All right, so I can't use the square root method. So we'll just use, for these, there's just always the standard. Find your a, b, c. And you just use the quadratic formula. That's c equals -1 there. All right, so here's the quadratic formula, negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. And we just substitute in negative. My b is 6. So that's the negative sign. The b is the 6. Plus minus. I have to take the b value 6 and I have to square it. Always put that in parentheses. In fact, I put all these things in parentheses to indicate multiplication. All right, I'm just going to work through this thing. The negative 6 stays, plus or minus the square root of, and you just work inside here. Square this first. 6 times 6 is 36. Then what I suggest you do is multiply 4 times 2 times 1 and go, that's 8. and then figure out the sign on it. So in this little multiplication here, I've got a negative, sorry, a negative times, negative 4 times a negative 1, so that's going to give me a positive number, so it's plus 8. All right, all over 2 times 2, 4. And so I get, let's see if he simplified this one. 36 plus 8 is 44 over 40. Leave any with a 44 inside? No, he's got 11s on the inside. So let's see if we can get an 11 out of this thing. So we go negative 6 plus or minus 44 is 4 times 11. I can square root that 4 inside there, giving me the square root of 4 is 2 root 11 over 4. Everybody's divisible by a 2. There's my best answer. Negative 3 plus or minus root 11 all over a 2. Negative 3. And it looks like it's that guy. Negative 3 plus minus a root 11 all over 2. Yep, that matches my answer over there. All right, the video may jump there because I have to edit a couple of them together here. Uh, Real quick though, I want to make sure because I kind of rushed when I had to quit recording here. So hopefully you recognize where I ended up here. So I've solved with the quadratic formula. Quadratic formula you have to have memorized. And then right here now, once I've done my, so 44 is 4 times 11. I can square root the 4, so that's a 2 on the outside. I can't square root the 11, so I leave it underneath the radical to say, hey, it's a square root of an 11. Um, and then what I want to do is look at these two terms and really to formally do it, I should separate these like this, right? This is like two fractions being added together, like negative 6/4 plus this 2 root 11 over 4, right? And they have a common denominator. So if I were to add them, I would just add the numerators and put them over 4. That's what this is. Now I've just done the plus one, but there's also the minus here. So just get my red pen. So it really looks like that. And then you simplify each of these fractions. So that's where the negative 3/2 comes from. These are both divisible by 2. So you do that. Um, and then 2 over 4, they're both outside the radical. So you can simplify that to a 1/2. Okay, so there would be one representation for it. There's a couple of representations for our answers. So this would be one form right here where you keep it over that denominator of 2. This is another form where you separate the rational part from the part that has the irrational root 11 in it. And that's what they did. They did this one right here where they separated them and simplified them. Okay. Um, so how do we know when to use the quadratic formula? That's always a question I think students have. It's like, why do we use it sometimes and not all the time? Well, the answer is, uh, what kind of answers is it going to have? And you don't know what kind of answers it's going to have until you try to solve it with all of our different methods. But a quick way to tell is to just grab your calculator, assuming you get a calculator. And I'll just make a new graph here. And you just type your equation in 6x squared minus 3x 31x, sorry, and then plus 40. And in this case, they've asked for the zeros of the function. If you look at the question there, it tells you find the zeros of it. So when you're looking for the zeros, what that means is figure out what the x's have to be in this equation in order for the function to equal 0, and hence the reason they're called zeros. And so when I graph this, I'm going to zoom in here and look where the y values are 0, and that's right at the x-intercepts. And see those x-intercepts, those are what we call rational numbers. What do I mean by rational? I mean, if I take, I want the one on the left here because it's clearly a rational one, 2.5. I can change it to a fraction. That means it's rational. So one of the answers here is x equals 2.5 or the fraction 5/2. Same number, different representations for it. The other one's a little tougher though, but it's 2.66666. And then they got a 7 there. But what I want to point out is this. If one of the answers is rational, the other answer has also got to be rational, which means this number 2.66667 it must be made into a fraction. It must represent a fraction. Now you have to know a little calculator speak. This is your calculator going 6, 6, 6, 6. Oh, I've run out of room. I'm going to round your next number. So this is really another 6, 6. It just keeps on going. This is 2.6, and it's a repeating 6. Our calculators can handle that. You just got to put in enough sixes so it will know that it's a repeating. Look how many I have to put in there. There we go. The fraction button came back, and it is equal to 8/3. You can even see it here. 8 divided by 3. There it is. It rounds that last digit up to 7 again, but it's not. It just keeps on going with a 6. So your other answer is not 2.6 repeating 6. We write the fraction 8/3. So there's the two solutions to our equation. You can see there they are. Now, uh, what if I don't get to use Desmos? Well, then you got two choices. Choice number one is you can go straight to the quadratic formula. Okay, this will trying to find. Let's write in a different. This equation or this formula is a formula that just tells you the answers every time. Right. The only problem with it is it takes quite a while to use. So uh, now that I know this thing has rational answers, these fraction answers, I also know that it factors. Okay, so I'm going to factor it real quick because if it factors, it has rational answers, or if it's rational, uh, if it factors, it has rational answers. If your answers are rational, that means it factors. So here I've done the Australian method, is what we're calling it, because you have to put a 6 down under. And I need two numbers that multiply to 24 or 240. That's the A times C, but they got to add up to a 31. So let's see here. 8 times 30. Nope, that won't quite get it. 3 times 24. That won't quite get it. 24. Oh, no. Is that 31? 24 and 10 don't get it. Let's see here. This is probably why you wouldn't factor. It takes a while. So I'm going to quickly pull up the factors of 24. Watch I do this on my Desmos. 1, enter. 2, enter. It just auto-populates, so I can just keep hitting enter. I put a bunch of numbers that I think I might need. Then I go to my first column. I just enter the number I'm trying to factor, 240, and I divide it by, and I type in X and the number 1, which is column 1. And I get this list, these XY pairs, things that multiply to 240. Now I'm looking for a pair that add up to a 31 in the middle. Oh, there we go. I see it now. 15 and 16. Those add up to 31. So I'll put a 15 in one, a 16 in the other, make them both negative. So they add up to negative 31. And let's see here. This one, these both divide by 3. And that means these both divide by 2, giving me a total of 6 that I'm taking out. There we go. So now it's factored. And once it's factored, I can set each factor, woo, equal to 0. And I take the 5 over, and you'll see I get divided by 2, 5 halves. And I take the 8 over, and you'll see I get 8/3. So exactly what I got by using my calculator at the very beginning. Okay. And again, if I couldn't get it to factor, so I couldn't get it solved with my calculator, I couldn't get it to factor, I could always use, oh my goodness, I really goofed it up. There we go. I could have used the quadratic formula. All righty. So hopefully we got that one answered. The larger root, that's another way of saying the larger solution, is closest to. eh, It looks like you get to use your calculator for this guy because it's a decimal, those decimal answers. So that means I'm just going to graph this darn thing. Get rid of that table. I got 3x squared minus 5x plus 1. Let's find out what his zeros are. I'm going to hit that little home button there. Well, find where it crosses the x-axis. Got two answers. The x is either 1.43426 or the x is 0.23241. And I'm just going to look here. The larger root, so that's this one, is closest to 1.43. Okay. Again, I'm assuming we get to use a calculator, and that one you definitely need it for. I think we got them all answered on that page. Let's jump to the second page here. Given this function, ooh, graph the function on the grid at the right. I don't know if he's giving you a calculator for this thing or not. I'll do it like I don't have a calculator, then I'll show you how you could do it with a calculator. So the first thing you want to know is what the heck does a square root function look like? And this one he should have you memorize. It's like I plug in a zero and then I have to square root the zero because x becomes zero and that's just zero. So zero zeros on my graph. I plug in a one, the square root of one is just one. So I'm going to graph a 1 on my graph. I plug in a 2 and I can't square root a 2 very well, so get it. I plug in a 3, I can't square root a 3. I plug in a 4, ooh, I can square root a 4. Square root of 4 is just 2, so when x is 4, y is 2. There's x is 1, 2, 3, 4. Y is 1, 2, 3, 4. I can't plug. I could plug in a 5, but I don't know what the square root of 5 is. The next number I can really plug in is a 9. So there's 5, 6, 7, 8, 9 is out here, and the square root of 9 is 3. I could also do a 16 next, 10, 11, 12, 13, 14, 15. I'm just going to make up a 16 out here because the square root of 16 is a 4. Let's get it over here a little bit. Okay. Now this is not the equation you're graphing. This is the parent function of what you're graphing. This function that you're actually graphing is shifted left by 2. It's always the opposite sign. You see an x plus 2, it shifts left. It's like x is a negative 2. It shifts up by 3. And then it's also flipped over. Darn thing is. All right. So what we're going to do is when you do these, your best move is to take care of any flips first and then just slide it left and right. Okay. In fact, that's pretty much the way you've got to do it. So let me lock this thing down here real quick. All right. Lock him so he doesn't slide on me. So let's first flip him upside down. Okay. And after I flip him upside down, so this point right here, I'm going to probably keep, let's see if I can turn that touch off. I don't think I can. So this point right there, I'm going to first flip him upside down, but when I flip him upside down over the x-axis, he stays right there. Then he's going to shift left by 2, and then he's going to shift up by 3. So there's where this new point's going to be. So I'm going to put one at -2, 3. -2, 3, and there is that point. Get my laser pointer again. And I'm going to do this with the next point. I'm going to flip it upside down. That's the negative sign out front. So it flips over the x-axis. It goes left by 2, and then up by 3. Right there. All right, so we're going to put another point right there. This isn't too bad. Now, there's a couple ways to do it from here on out, right? So one way would be we can just follow the pattern. There's the right one, up one, right one, down one it became. And then it goes from there, it goes up 1 over 3. So it's going to go down 1 over 3 like this. And my next point's going to be right there. Or I can keep working the way I was. I'm going to take this point. I'm going to flip him upside down. I'm going to move him left 2. And I'm going to move him up 3. Right there, he's going to be at 2, 1. Oops, change colors on you. Became blue again. Let's just keep on going. So that's my third point. Now I'm ready for the fourth point. He's up here at 3, so I flip him upside down at -3. I move him left by 2 units. I move him up by 3 units to take care of my shift, and I'm right there. That looks like it's at 7, 0. So I'll put another point at 7, 0. And this last point, let's go ahead, since I did draw him in there, we'll go ahead and find him. So he's up above the x-axis by 4. So now he'd be down below the x-axis by 4, way out here. Then he'd get shifted left by 2, and he'd be shifted up by 3. Right there he'd be. That's at what, 9, 10, 11, 12, 13, looks like 14, -1. 14, -1. I think that's him right there, but I'll double check him by looking at this point saying, oh, it's up 1 over 1, 2, 3, 4, 5. So I'll start here. I'll go down 1, 1, 2, 3, 4, 5. Well, that doesn't seem, oh, that's the wrong point. Up 1 over 1, 2, 3, 4, 5, 6, 7. So down 1 over 1, 2, 3, 4, 5, 6, 7. That's the right point. And there is my graph. So it's the blue one, and then you go back if you need to, and you erase that guy. You say, that's not my graph. That one's my new graph. That's what the f of x, my f of x equal to the negative of the square root of x plus 2 quantity plus 3 looks like. Upside down, shifted left 3 from the origin, or sorry, left 2 from the origin and up 3. Okay. Oh, explain how the graph has been transformed. Okay. So real quick, if I was going to graph this on Desmos, I would just graph, you don't even have to have the f of x in there. Square root like this, x plus 2, arrow to the right, so you're outside the radical sign, and then plus 3. And then you just want to steal this endpoint here. It's kind of hard to steal there, but there you go. I can drag above him kind of. And so -2, 3 is where it starts. And you can see I've graphed that point, -2, 3 right there. Okay. Um, Another good point, if you do this correctly and do it with the f of x, like so, just get my x in there and get my equal sign right there. Then you can just ask it some questions. Once you found where this thing starts at, you know, it's at x is -2, and you go like, hey, what happens if x is -1? And it gives you the point -1, 2. You could ask it like, what happens at 0? But 0 is not a good point to graph. Then you'd say, what happens when x is 1? Not a good point. X is 2. Ooh, x is 2, out comes a 1, so I could graph that point. And you just keep testing points till you find good points, like so. I think my next good one's at 7. Yeah, at 7, I get a 0, and that's this point. Okay, so that's how you can graph it. Um, Now, this transformation stuff, I was alluding to that, or I talked about that right up here. How is this thing different? So we just write these things. Number one was the reflection we did. So we say it's reflected over the x-axis. Okay, so that was the flip upside down, the negative sign out in front. It was shifted, or let's get really formal here for your teacher, translated. We had to slide it left by 2, right? So it was, here's the original that goes up like this. It was flipped upside down, then it was slid left by 2. And 3, it was translated up by 3. That was at 3 on the outside right there. Domain and range of f of x. Let's see here. Now that I've got it graphed, I can check my domain. So what's the lowest x value it started at? It started at -2. That's the lowest x. And then the graph goes down and to the right. We want the right stuff because the right is x. So it started at -2 and then it went right forever. So we'd say your domain is x's are greater than uh, or equal to the -2. Or if he likes interval notation, you say, hey, it started at -2 and then it went to the right forever. So we just put an infinity in there. Either one. You don't put both, though. You just put one of those unless he wants both. That's just different notations for the same answer. And then our range. Well, range has to do with our y-axis. So we look at what's the highest y value it went to. It went up here to a 3. And then all these y values it went down. And right now we're curious about the down part. The down, it goes down, down, down forever and ever and ever. So it had a high point of 3. If I was thinking about a number line, the highest it went to is 3. And then it went less than the 3. So we say, hey, x's are less, oops, sorry, y's are less than or equal to a 3. Or as an interval, we'd say from -infinity all the way up to the 3 inclusively. Remember, you always put the low number on the left, and -infinity is much lower than 3. So again, one of those answers. Now we're going to solve this one algebraically. This is great to do this one. Here, this is a radical equation because you have a radical here and there is an x under it. Okay, that's what makes it radical. And when you have a radical equation like this, you want to get the radical alone. So I got a left side and the right side to my equation. I don't want that one over there, so I'm going to throw it to the other side. Now, my radical is almost alone. It still has that negative sign in front of it. And that's okay because it's a negative sign. I'm just going to square this side now. Okay. Now on the left side, you got to be a little careful because this is really what this means, x minus 1 times x minus 1. So if I multiply those together, um, do all my distribution, this outside product is negative 1x. This product is negative 1x. So I get negative 2x on the inside and then negative 1 times negative 1. So that's what that multiplies to. This side, I square it, so I get negative times negative, it becomes positive. And when you square a square root, those two just cancel each other out. It just becomes 17 minus 2x. Okay, I'm gonna get this thing equal to 0 now. I'll subtract my 17, I'll add my 2x, and I'll add my 2x. And I get x squared minus 16 equals 0. Huh. So x squared equals 16, so x equals plus or minus 4, square root both sides. And now I got to check them. Says check your solution. So let's check them in the original equation. 1 minus square root 17 minus 2x. I think one answer is a 4. So I'm going to put a 4 in for my x's and see if the left side equals the right side. The left side just says I'm 4. The right side says I'm 1. That's a question mark that looks questionable. I'm 1 minus the square root of a 17 minus 8, which is 1 minus the square root of 9, which is 1 minus a square root of 9. Oh man, that comes out to negative. Oops. 1 minus 3 that comes out to negative 2. That did not check at all. So my 4 didn't work. Let's try my negative 4. So negative 4 equals 1 minus square root of 17 minus 2 times negative 4 again. Not equal to until I prove it is. That's what I'm checking. So this says 1 minus the square root of 17 plus 8, which is 1 minus square root of 25, which is 1 minus 5, which is negative 4. That one does check. And so I get two solutions, but x equals negative 4 is the only one that checks. And so that is my only answer. All righty, that's all of them. Boy, that tough stuff there. Hope that helps you out.